What if I told you that one of the coldest, most distant worlds in our solar system has a beating heart? Not a biological one, of course, but a vast geological heart made of frozen nitrogen that rhythmically contracts and expands, driving weather patterns and shaping the entire surface of the planet. This isn't science fiction, this is Pluto. For decades we imagined it as a simple, inert ball of ice and rock, a forgotten outpost at the edge of our cosmic neighborhood. We couldn't have been more wrong. The story of Pluto is not one of a dead world, but of a dynamic, complex, and surprisingly active place that challenges everything we thought we knew about how planets work, especially those shivering in the deep freeze of space. This massive heart-shaped feature, officially named Tombaugh Regio, is more than just a charming planetary tattoo. Its western lobe, a 600-mile-wide basin called Sputnik Planitia, is a colossal glacier of exotic ices. The story of Pluto begins not with a telescope, but with a mathematical puzzle. In the late 19th century, astronomers noticed something strange about the orbits of Uranus and Neptune. Their paths through the heavens wobbled, deviating slightly from the predictions of Newton's laws of gravity. Something massive and unseen had to be out there, a ghost in the machine, tugging on these gas giants from the darkness. The hunt for this mysterious Planet X was on, and it captivated one wealthy Bostonian amateur astronomer, Percival Lowell. He was so obsessed, he built an entire observatory in Flagstaff, Arizona, dedicated to finding it. Lowell calculated the likely position of Planet X, and began a systematic search in 1906. But he died a decade later, without success. The quest, however, did not die with him. The Lowell Observatory continued the search, and in 1929, they hired a young man from a Kansas farm who had no formal university training in astronomy, but possessed an incredible skill for painstaking observation. His name was Clyde Tombaugh, and he was just 23 years old. His job was monotonous and grueling. He had to take long exposure photographs of the same patch of sky on different nights, and then meticulously compare them using a machine called a blink comparator, looking for any tiny speck that had moved against the backdrop of fixed stars. Then on February 18, 1930, he saw it. A faint dot, just as predicted, had shifted its position between plates taken on January 23 and January 29. After careful verification, the Lowell Observatory officially announced the discovery of the ninth planet on March 13, 1930, Percival Lowell's birthday. The world was electrified. The solar system had a new member. When Pluto was first discovered, astronomers believed it was a sizable world, perhaps as large as Earth or even larger. But as our observations improved, Pluto began to shrink, dramatically. Its diameter is about 1,473 miles. If you were to place Pluto on a map of the United States, it would stretch roughly from Denver to Indianapolis. In contrast, Earth's diameter is nearly 7,917 miles. You could line up more than 5 Plutos side by side to match the width of our home planet. Pluto's mass is only about 0.2% of Earth's. If you weigh 150 pounds on Earth, you would weigh a mere 10 pounds on Pluto. Imagine an atmosphere so thin, the pressure on the ground is 100,000 times less than on Earth. An atmosphere you could barely feel, that is almost a vacuum. This is the sky of Pluto. And yet this incredibly tenuous envelope of gas is one of the most complex and visually stunning features of this distant world. When the New Horizons spacecraft flew past Pluto and looked back towards the sun, it captured one of the most breathtaking images in the history of space exploration, a brilliant multi-layered blue haze encircling the dark sphere of the planet. This atmosphere is primarily composed of nitrogen, just like Earth's, but with significant traces of methane and carbon monoxide. What makes it so fascinating is its dynamic relationship with the surface. Pluto travels on a highly elliptical orbit, taking 248 Earth years to circle the Sun. As it moves closer to the Sun, the surface ices warm up just enough to sublimate, turning directly from solid to gas, which thickens the atmosphere. As Pluto journeys away into the colder depths of space, the atmosphere freezes and falls back to the surface like snow. Pluto essentially breathes, inhaling and exhaling its atmosphere over the course of its long, slow year. So where does that beautiful blue color come from? It's not from scattered light in the same way Earth's sky is blue. On Pluto, ultraviolet light from the distant sun strikes methane gas high in the atmosphere. This solar radiation breaks the methane molecules apart, triggering chemical reactions that create more complex hydrocarbon compounds, like acetylene and ethylene. These compounds clump together to form tiny, soot-like particles called tholins. These tholins are what we see as the haze. They scatter blue light, giving Pluto's atmosphere its ethereal glow, while they absorb other colors. Before the New Horizons flyby, the consensus was clear: Pluto had to be a geologically dead world. At nearly 4 billion miles from the Sun, it receives so little energy that its surface is colder than liquid nitrogen. Any internal heat from its formation should have radiated away billions of years ago. But what New Horizons revealed was a world that was shockingly, bewilderingly alive. Instead of a uniform field of craters, we saw towering mountains of water ice, vast smooth plains of frozen nitrogen, and clear evidence of geological activity that may have occurred in the very recent past. The most dramatic features are the mountains. Some, like the Norgay Montes and Hillary Montes, soar up to 11,000 feet high. That's as tall as the Rocky Mountains on Earth. But these are not mountains of rock. They are mountains of water ice. Perhaps the most mind-bending discovery was the possibility of cryovolcanism, ice volcanoes. Scientists identified two large mountains, Wright Mons and Pickard Mons, that have deep depressions at their summits, looking uncannily like shield volcanoes on Earth or Mars. But instead of spewing molten rock, these cryovolcanoes would have erupted a slushy, partially melted mixture of water, nitrogen, ammonia, or methane from Pluto's interior. The leading theory is that Pluto has a subsurface ocean of liquid water, kept from freezing by the antifreeze properties of ammonia and residual heat from the decay of radioactive elements in its rocky core. Pluto has transformed from a simple ice ball into a complex, active, and deeply mysterious world. The story of modern Pluto is, honestly, inseparable from the story of a machine named New Horizons. Launched on January 19, 2006, this piano-sized spacecraft was the fastest ever built, flung away from Earth at over 36,000 miles per hour. Its mission was audacious: to cross nearly 3 billion miles of space for a one-shot, high-speed flyby of a world we had only ever seen as a blur. For 9.5 years, it journeyed silently through the void. For him and his team, this was the culmination of a lifetime of work. At 8:52 p.m. Eastern Time, the signal arrived. A faint stream of data, confirming that New Horizons was healthy, and had successfully completed its primary mission. The control room erupted in cheers and tears. The unknown had been visited. Over the next 16 months, the spacecraft slowly beamed back its treasure trove of data, thousands of images and measurements that would forever change our view of Pluto. The first close-up images were astonishing, revealing the heart-shaped glacier, the towering ice mountains, the blue haze, and the complex surfaces of Pluto and its moons. It was like seeing a new continent on Earth for the first time. Just months after New Horizons began its long journey to Pluto, the world it was destined for underwent a dramatic identity crisis. In August 2006, the International Astronomical Union, the official body responsible for naming celestial objects, met in Prague to vote on the very definition of a planet. For 76 years, Pluto had been our solar system's 9th planet, a fact taught in every classroom. The IAU proposed a new 3-part definition. To be a planet, a celestial body must first orbit the Sun, second, be massive enough for its own gravity to pull it into a nearly round shape, hydrostatic equilibrium, and third, have cleared the neighborhood around its orbit. Pluto meets the first two criteria with ease. It orbits the Sun and it is definitely round, but it fails on the third. Its orbit is full of other Kuiper Belt objects, a cosmic debris field it has not managed to sweep clean. Based on this new rule, Pluto was reclassified. It was no longer a planet, but the prototype for a new category, the Dwarf Planet. The decision was, and honestly still is, intensely controversial. Many planetary scientists, including New Horizons' Alan Stern, vehemently disagreed. But this debate, as frustrating as it was for some, had a profoundly positive effect on science. It forced us to think more deeply about what a planet truly is. The controversy ignited public interest in astronomy like never before. The debate transformed Pluto from being the smallest and weirdest of the planets into being the largest and most important of a vast new population of worlds in the Kuiper Belt. In a way, the reclassification made Pluto even more interesting. Pluto does not travel alone. It is locked in a gravitational dance with its largest moon, Charon. Discovered in 1978 by astronomer James Christie, Charon is enormous relative to Pluto, about half its diameter and over 1/8 its mass. This is no ordinary moon. The two bodies are so close in size that their relationship is more like a binary system. They are tidally locked, meaning they always show the same face to each other as they orbit a common point in space called the barycenter, which lies outside of Pluto itself. Imagine looking up from the surface of Pluto. Charon would hang motionless in the sky, a huge, silent companion that never rises or sets. When New Horizons flew past, it didn't just study Pluto. It gave us our first ever close-up look at Charon, and what it found was just as surprising. Charon is a world of its own, with a dramatically different history. Its surface is dominated by water ice, not the exotic nitrogen and methane ices that cover Pluto. It has vast, deep canyons, one of which, Argo Chasma, is more than 4 times deeper than the Grand Canyon. Most strikingly, its northern pole is capped with a mysterious dark red stain, nicknamed Mordor Macula. Beyond Charon, Pluto is the patriarch of a small family of 4 other, much smaller moons: Styx, Nix, Kerberos, and Hydra. These tiny, irregularly shaped moons are not neat and orderly. They tumble chaotically as they orbit the Pluto-Charon barycenter, their rotation rates and orientations constantly changing in unpredictable ways. This chaotic dance is a result of the complex and shifting gravitational field created by the 2 larger bodies. This entire system, Pluto, Charon, and their 4 small children, is thought to be the result of a massive collision deep in the solar system's past, when another large Kuiper Belt object smashed into a proto-Pluto. This family portrait is a microcosm of the entire Kuiper Belt, a third zone of the solar system beyond the rocky inner planets and the outer gas giants. So, Pluto is not the 9th planet. It's a dwarf planet, the king of the Kuiper Belt, a complex and active world with a beating heart of nitrogen, towering mountains of ice, and a family of chaotic moons. It was discovered by accident, its size was mistaken for decades, and its reclassification sparked a global debate. Its story is a winding path of mystery, misconception, and brilliant discovery. But the ultimate question is, why should we care? Why does this small, cold world billions of miles away matter so much? The answer is that Pluto represents the frontier. Not just a physical frontier at the edge of the known solar system, but a scientific one. Every time we thought we understood Pluto, it surprised us. It defied our models and shattered our assumptions about how worlds work. It taught us that geology can be active in the most extreme cold, that atmospheres can create organic compounds far from the sun, and that the category of planet is more complex and wonderful than we had imagined. Pluto is a powerful reminder that the universe is not obligated to conform to our expectations. It is a lesson in scientific humility. The journey of New Horizons did not end at Pluto. It is now venturing deeper into the Kuiper Belt, having already visited another, even more primitive object named Arakoth. It continues to push the boundaries of our knowledge, exploring the very edge of our cosmic home. The story of Pluto is not over. In many ways, it has just begun. The data from that single flyby will keep scientists busy for decades, and it has already inspired proposals for a new mission, an orbiter that could stay at Pluto and watch its seasons change over many years, unlocking even deeper secrets. Pluto matters because it embodies the spirit of exploration. It's a story about looking at a faint, fuzzy point of light and asking, what is that? It's about building a machine to travel for a decade across the solar system just to find out. It's about being completely wrong in our predictions and being thrilled by the beautiful, complex reality. Pluto is no longer the last planet, it is the first world of a new frontier, and it has forever changed how we see our place in the cosmos, reminding us that even the smallest, most distant specks of light can hold the greatest wonders.